Now in this video, we will try to understand what are destructors. So far we have seen a lot about constructors. Now what are destructors? Destructors are used to deallocate memory that was previously allocated for object creation. Constructors will construct objects, will create them, will allocate memory for them. Destructors will do exactly the opposite. That means they will deallocate the memory, or it will take your objects out of scope once the program is exited. Now, destructors will be invoked in three cases. Number one, if the control exits a block of code. A block of code is anything that is delimited by braces, right? An opening brace and a closing brace defines a block. So, if the control exits a block, the destructor will be invoked. The destructor will also be invoked if the control exits a function, and the destructor will also be invoked if the program comes to an end. So these are the three cases in which a destructor is invoked. Also, there are some properties of destructors. Property number one is a destructor has the same name as the class. Just like a constructor has the same name as the class, a destructor also has the same name as the class. Remember, like constructors, destructors do not return any value, not even void. But there is one difference with constructors. Constructors may or may not take arguments. Depending on that, we have discussed various types of constructors. You have default constructors, parameterized constructors, copy constructors, but destructors, remember, will never take any arguments. Why is it so? The question may be asked that why does a destructor never take an argument? The destructor will never take an argument because the assumption that C++ makes is there is only one way to destroy objects. The assumption that C++ makes is that there is only one way to destroy an object. As a result, a destructor will never take an argument. There are multiple ways in which an object may be constructed. That is why you have different types of constructors. An object may be constructed with no argument, so you use the default constructor. An object may be constructed with one argument, so you use a parameterized constructor. An object may be constructed with 3 arguments, you use another parameterized constructor. An object may be constructed using the values of another object which has been previously created, so you use a copy constructor. So there are various ways in which you can construct object, but the assumption is that the destructor will work in only one way to destroy objects. As a result, it will never take any arguments. Okay? And another point is that a destructor is preceded by a tilde. See, this is how you would identify a destructor. A destructor is identified by having the same name as the class, by taking in no arguments, and also it is preceded by this symbol, and this symbol is called tilde. Tilde. This is called a tilde. This is called a tilde. Okay, so a destructor will also always be preceded by this symbol tilde. And remember, one last point is, another very important question that is often asked is, can destructors be overloaded? See, we saw that constructors can be overloaded, right? Now the question is, can destructors be overloaded? Pause the video and think about it for a moment. The answer is no, destructors cannot be overloaded. Why? Because destructors will never take any arguments. So the argument list of the destructor will always be empty. And we know that overloading, whether it be function overloading or constructor overloading, is done based on the number and type of arguments and also the position of the arguments. Since a destructor will never take any argument, there is only one way to define a destructor, and as a result, a destructor can never be overloaded. Please keep this in mind. A destructor can never be overloaded because it will never take any arguments. As a result, all destructors that you create for all types of programs will have the same destructor line definition header. This is the destructor line definition header. This will be the same for all programs that you create. Okay. Now, having understood all these points about destructors, and I hope you have jotted them down in your notebook. If you haven't, then please rewind the video, pause them from time to time, pause the video from time to time, and note it down. These points were very important. Now let's come to this program execution. So I have defined a class called alpha. Now, contrary to object-oriented programming, just for illustration purpose, I have defined a global variable. But remember, in object-oriented programming, one purpose for coming up with object-oriented programming over structured programming was to eliminate the use of global members. But here, just for illustration purpose, I have used a global variable called count, and I have given it a value of 0. Now I have a constructor in my public section, And that constructor, what is it doing? It is simply incrementing the value of this global variable count, and it is also printing a statement that object is created. So it's printing a statement object created, and it is followed by the current value of count. Similarly, you have a destructor. You have a destructor called alpha, obviously, because it has the same name as the class, and it is preceded by tilde. So here I am saying that object is destroyed, and I am printing the value of count. And after the value is printed, and after the statement is printed, I am decrementing the value of count by 1. So here the value of count is incremented by 1. Here the value of count is decremented by 1. This value of count, what it does is, you can probably understand, it keeps a track of the number of objects, or the object number rather, not the number of objects, the object number which is currently being worked with. So if I'm working with the first object, so I say it is object 1. If I'm working with the third object, I say object 3. If I'm destroying the fifth object, I say that object 5 is destroyed. So it's like that. And in my main, now see, how will the execution take place? So what did I say? I said that destructors will be invoked in 3 scenarios. One, if the control of your program leaves a block. What is a block? This is a block. See, this is a block of statement. This is another block of statement. So whenever your control enters a block, and after entering the block, when the control leaves the block, once it leaves the block, the destructor is invoked. The destructor is invoked once it leaves the block. The destructor is also invoked when the control leaves the function. And the destructor is also invoked when the control leaves the program. That means your program comes to an end. So these are the 3 scenarios when the destructor is invoked. Now let's see how this program will run. Now see, I'm saying cout main. So first, the statement main will be printed, and now I'm creating 4 objects at a time. See, I'm creating A1, A2, A3, A4, 4 objects, and none of these objects are taking in any arguments. That means the default constructor is invoked. So because of this, the default constructor will be invoked. So first, the default constructor will be invoked for A1. What will happen? First, the value of count will be incremented by 1. So let's say the value of count, where do I write the value of count? Let's say I write it here, okay? So initially, the value of count is 0. So initially the value of count is 0. I have in the constructor is invoked for creating the object A1. So the control comes here, the value of count is changed from 0 to 1. And what happens? This statement is printed, object created 1. So what do I get? I get object created 1. Next, what will happen? The constructor will again be invoked for A2. The same thing will happen. First, the value of count will be incremented. It will become 2. And then this statement will be printed. What will be printed? Object created 2. Then again the constructor will be invoked for A3. What will happen? The value of count, see, the value of count will first be incremented by 1. So count will become 3, and then you will have the statement printed, object created 3. Like this, it will be the same for A4. So the constructor is invoked automatically. The count value is increased by 1, so count becomes 4, and this statement is printed, object created 4. So object created 4, right? So this is what will happen for these 4 statements. Now I'm entering a block. See, I have defined a block of statements. So I've defined a block of statements. Now what I'm saying? I'm saying cout block 1. So after all these statements are printed, I hope you have noted down the output. So after all these statements are printed, what will happen? Now the current value of count is 4, as you can see. So I enter a block and I print this statement, block 1. So I print the statement block 1, and after printing the statement block 1, what do? I create an object A5 of class alpha. So the moment I create this object, what happens? The constructor is invoked, and then you increment the value of count by 1. So count will now become 5. So the value of count becomes 5. And after creating this object A5, I come out of this block. So the moment I exit the block, what will happen? The destructor will be invoked. So at this point, the destructor is invoked. And what will happen? This statement is first printed, object destroyed. So I have to print the statement, object destroyed, and then I'll print the value of count. So the value of count is 5. So I'll print object destroyed 5, and then I'll decrement the value of count by 1. So count will change from 5 to 4. Next, what will happen is, again you enter a block. So I'm entering this block now. See, I'm entering this block. This is the block that I'm talking about. So once I enter this block, what will be printed? First, block 2 will be printed. Okay. So block 2 is printed, and then what will happen? Another object is created. Alpha 6 is created. So alpha A6 is created. So control will pass to my constructor, and what will happen? The value of count will be incremented. Okay, the value of count was currently 5. I'm sorry. The value of count was 5. And then now the value of count, so the value of count then became 4. So I was right, right? Because of the destructor, the value of the count again became 4. Now because of this statement, alpha A6, what will happen? The control will be transferred to the constructor. The value of count will be incremented by 1. So count will become 5. And then this statement will be printed. Object created. So it will be printed object created, and then the value of count will be printed. What is the value of count? The value of count is currently 5. So 5 will be printed. And the moment I exit the block at this point, the moment I come out of the block, the destructor is invoked. And because the destructor is invoked, what will happen? Object destroyed. The statement will be printed. So I'll print the statements. I'm erasing this. So I'll first print the statement object destroyed, followed by the value of count. What is the value of count? The value of count is 5. So I'll print the value of 5, and then I'll decrement the value of count by 1. So count becomes 4. So you have seen two cases where the constructor was invoked, right? I mean the destructor was invoked rather. See, the destructor was invoked when I exited this block. The destructor was again invoked when I exited this block. So this was one scenario where the destructor is invoked once you exit a block. Now what happens? This statement is printed, re-enter main. So re-enter main. This statement is printed, and now it says return 0. That means the program comes to an end. The moment the program comes to an end, at this point, the moment the program comes to an end, the destructor is invoked one last time. And what will happen? All objects will be destroyed. That means first you will have, so I'm erasing this. So first you will be destroying 4. So you will destroy object, so you will print object destroyed, and the value of count. What is the value of count? 4. So you will print object destroyed 4, and then you will decrement the value of count by 1. So count becomes 3. Then again you will print object destroyed 3. So it will be invoked how many times? It will be invoked 4 times. It will be invoked 4 times, because remember, at this point you have 4 objects currently in your system. See, A1, A2, A3, A4 are still there. See, A5 was created the moment you exited this block. A5 was destroyed. Then again you entered this block, A6 was created. The moment you exited this block, A6 was destroyed. So what are the objects remaining? A1, A2, A3 and A4. Now each of these objects will be destroyed. And for destroying each of these objects, the destructor will be invoked once. So for destroying A4, the destructor will be invoked once. For destroying A3, the destructor will be invoked once. For destroying A2, the destructor will be invoked once. And for destroying A1, the destructor will be invoked once. So first, A4 will be destroyed. So this destructor will be invoked, and you will print the statement object destroyed 4. Then A3 will be destroyed, and the statement will be printed object destroyed 3. And after printing object destroyed 3, you will decrement the value of count by 1. So count will become 2. And then again, what will happen is, for A2, for destroying A2, this destructor will be invoked, and you will be printing object destroyed 2. And the value of count will decrement by 1. And then again, for destroying A1, this destructor will be invoked, and you will print object destroyed. So you will print object destroyed, and then the value of count. So what is the value of count? The value of count is 1. And then the value of count is finally decremented to 0, and the program execution comes to an end. So remember, from this program execution, what conclusion can we draw? The conclusion that we can draw is, remember, you can just note this down. Destructors are invoked every time an object has to be destroyed, and objects are destroyed in reverse order of creation. If you note the order in which the objects were created, first A1 was created, then A2, then A3, then A4, then A5, and then A6. See, A5 and A6 were not created together. At one point in time, you had A1, A2, A3, A4, and A5. The moment the control exited the block, A5 was destroyed because it was the latest object to be created. After A5 was pulled out of memory, A6 was created, and the moment you exited the block, A6 was destroyed. Why? Because it was the latest object to be created. and the moment you exited the entire program, the objects that were there right from the start, A1, A2, A3, A4, they were destroyed one by one, and they were destroyed in the reverse order. So remember, objects are destroyed in reverse order of creation. So first A4 was destroyed, then A3 was destroyed, then A2 was destroyed, and then A1 was destroyed. So I hope this helps. You can leave your doubts in the comment section below. Thank you so very much.